Last lighting talk of the day. If you're interested, this painting is called The Baker, but we will get to that later. Now, I was told that we're in lunchtime, so I should come up with something a little bit dramatic and controversial to get your opinion. So let's go with this. Boom! Not that controversial, I see. Okay. Who here hates legacy code? Okay, that's almost all of you. Those that didn't raise your hands, I assume you are the ones writing it. Now, I haven't introduced myself, which is incredibly rude. My name is Josef Goldstein. I work for a company called Wix. I'm leading the R&D group responsible for our big data platform. I've been working professionally in software for about 17 years. So everything that I'm going to say right now coming from that experience. Unfortunately, I've been spending the last decade as a manager. And I also hate legacy code, but I am willing to admit on this stage today that I also write legacy code. Or, at least I used to, because I'm a manager and all, so I don't get to write a lot of production code these days, though if you're interested to see what happens when I write code, come to the talk tomorrow. You might be familiar with this story, because you might have gone through it yourself. You start a new position in a new company, or maybe another team in the current company that you work in, and you're genuinely excited. You want to prove yourself. You want to bring an impact. You're full of hopes and dreams. And then you open the code. What? Why is it built this way? Who built it this way? Were they suffering of some kind of an affliction when they wrote this? Does this even work? I'm pretty sure it doesn't work. And even if it does, it works by mistake. And as the rate of WTF raises in your head, that was a Freudian slip there right there. As the rate of WTF raises in your head, so is the frustration and the understanding that there is only one thing that you can do with this code. You have to rewrite it all. Because this code, this steaming, heaping pile of code, is standing between you and your goal to bring impact, to prove yourself. Because this is legacy code. Legacy code sucks. And the way we bring impact in legacy systems is by rewriting them. Well, yes, but actually no. Who here is familiar with Joel Spolsky? Joel Spolsky, the co-founder of Stack Overflow and Trello and a bunch of other stuff. Maybe you don't know that Joel is actually the author of what I think is one of the best software engineering blogs in history, called Joel on Software. Homework for all of you to go and read literally everything there after this. And in one of his blog posts from 2005, he tells the story of his first job, and that was before he went into software. That was a job in a bread factory, in a bakery. In his story, he tells the story of his first day at the bakery. He was shocked by what he found. The machines were rusting, the ovens were old and yellowing, there was grease everywhere. How are people willing to eat the bread coming out of this place? At the end of the day, Joel went to the bread factory's manager and he told him about all the stuff that he saw. The manager looked at him in a confused face and said, I don't know what you're talking about. We just finished cleaning. This is the cleanest this place has been in weeks. It took Joel months of trying to clean the uncleanable until he understood. He understood what clean means in a bread factory. You see, the grease, the horrible grease, it was actually important for the machines to function. Cleaning that grease was a mistake. The ovens, they were old and yellowing, but that didn't change the flavor and the quality of the bread that was coming out of them. Now, at this point, all of you are asking yourself, Joseph, what the hell are you talking about? This is the developers conference, not the bakers conference. Now, obviously, this is a metaphor. It's a metaphor to how our brain works when we meet new code, when we meet new things. You see, our brain works in models. We are building complex models for the code that we built. This is how we are able to traverse very, very complicated architectures. This is how we solve complicated bugs. the more we work on a piece of code, the stronger and more cohesive that model becomes in our head. The problem starts when we meet something new, a new model, a new piece of code that doesn't match any of the models that we have in our head. A model that we didn't take the time to build, to structure. We were not part of that. Our body responds a little bit like an immune system. It tries to reject this new model because we are all inherently biased against code that we didn't write, against models that we didn't take the time to build. This becomes even worse if what we meet kind of looks like something that we worked on. It kind of matches one of the models that we have in our head, but not quite, making it fall into the uncanny valley of code, which makes us feel anger and disgust. No, we will not be building this model in our head. We will be resisting it. We will be wishing bad things on the people that wrote that code, that built that model, and we will put a big sticker on it that says legacy code, because everyone knows that legacy code sucks. And the only thing we can do with legacy code is to rewrite it. But maybe, just maybe it's like the bakery. This code might be old and yellowing, but it brings value that it was built to bring. Or maybe you're right. Maybe you're right. You see, there are good reasons to why you would want to rebuild the model. Genuinely good reasons. The code, the model, was built to solve a problem, to fit the world in one way or another, but sometimes the world deviates from the model to the point of irrelevancy. I hope they're going to let me in England after making this joke. It made sense at the time. At the time, it made a lot of sense to put that there. But the world has changed since then. The model doesn't fit it anymore. It doesn't bring the value that it was built to bring. It became more and more antiquated. It makes less and less sense, despite the fact that people that build it might really still love it. So that's one good reason to why you would want to rewrite it all. Another reason, writing code, building models is a team effort, right? We're building code as a team. Here's another metaphor for you. Building these models is like building a maze. For the team that built it, it is beautiful. They understand it. They know how to extend it, to expand it, to traverse it. But unfortunately, the team is not a static thing. While the model might be good, might be well thought out, people come and go. And the original creators that had a good idea, had that model in their head, are not working there anymore. They're not there to guide people, guide the team anymore. And then new people come along, and they don't spend the time on building that model. And that's when the bad stuff starts to happen. That's when the hacks start to appear. It's people that haven't made the time to build the model in their head, but they try to get things done in any way possible. And what was once a beautiful maze, a well thought out model, becomes a big ball of mud. And it's just a collection of hacks, tricks, and emergency hot fixes. So that might be a good reason to rewrite it all. And even if things are going well, if the model still works, if the team is still there, technical debt can also get out of control a little bit, to the point that there's simply only one thing that we can do. But how will we know, right? How will we know whether it is us, the biases in our head, the unwillingness to build a new model, to learn a new bakery, or if it's the model that is truly flawed? Well, the first part is acceptance. You need to accept that this code is now yours. Congratulations. You need to understand it, not only how it was written, but why it was written. What value was it built to bring? How are we going to be doing this? It's going to sound really horrible, I know. We're going to have to read it. We're going to have to read all of it. We'll have to document it, document the stuff that we understand, the stuff that we don't understand. Talk to the people that built it, in case they're still around, and the people that survived maintaining it, and see what they learned. And then once we've done that, we'll be writing a little bit of black box testing, so we better understand how it runs. And then a little bit of unit testing, so we can better trust it. And then a little bit of refactoring, carefully, until we've built the model in our head, the bakery, the maze. Only then, we might decide to rewrite it anyway. Because, if I'm being honest here, the right question is not whether you should be rewriting it. The right question is when. You see, we sadly all know the truth, that all code, even the code that you are writing today, it doesn't age like fine wine. It ages more like milk. Legacy code doesn't really have an age. I have seen legacy code that is 10 years old. I have, unfortunately, seen legacy code that is 6 months old. The point is that if we really want to bring an impact, we can't allow ourselves to replace something before we truly understand it, before we spent the time building the model, understanding the bakery, the maze. Legacy code might be old and yellowing, but it was built to bring value. Only once we understand this value can we truly build it better. Until, of course, someone else comes along and rewrites also what we wrote. Thank you all. If you want to continue this talk, if you want to tell me that I'm wrong, you can find me on LinkedIn and on Twitter. Thank you. Have a great conference.